it's time to slowly get started. So in the next 40 minutes or so, we'll be talking about IoT and especially what we are doing at Eclipse for providing open source technology that help you implement IoT solutions. So we've been doing this for the past 5 years, actually. I'm with the Eclipse Foundation myself, and we are, as you may know, providing lots of the open source software that you require for building IoT. Just maybe a quick show of hands. How many of you guys in the room would consider themselves IoT developers? Okay, let's see. Let's try another one. If I say MQTT, does it sound familiar? Interesting. Not necessarily the same people, actually. Okay, so I like to start with this as an intro, especially when I'm in the Silicon Valley, I guess. IoT, yes, there's lots of gadgets around IoT, right? Everything home automation, putting a sensor somewhere on your dog, a GPS sensor, so as you can track where the dog is going, sure. That's not like, what's the point of just putting a sensor for the sake of putting a sensor? It's, for me, it's really about thinking first about the kind of solutions and the kind of applications for IoT, rather than thinking, yeah, let's create a freaking cool gadget for my for dogs and let's call it IoT. It's rather how can we improve, I don't know, the health of our pets, and then maybe it will boil down to being able to track their activity and quantify how much food they're getting every day. And so for that, at some point, yes, you will need to create some kind of equipment, and by means of sensors that will get data, or by means of actuators that will allow you to effectively interact with the physical world, then yes, you'll be able to access the data, and that's where the value of IoT is, and especially if we go beyond the pure consumer market, this is where you can really change things, like think industry, right? If you start being able to predict whenever an engine is going to fail because you, back to the interaction with the physical world, you have maybe a vibration sensor on the engine, and you have lots of data analytics, etc., then that's actually interesting. So how do you bridge the physical world to the internet? Well, this is where most of the new stuff, I guess, coming from IoT will come into play, maybe new dedicated protocols, new frameworks that you will require to effectively implement the embedded software that's required in the field, right? And there's also lots of stuff, let's be honest, that's existing technology, right? It's not like the IoT is reinventing everything. And so yeah, that's kind of the typical IoT architecture, probably oversimplified, but how do you get from the physical world to the actual applications that I was mentioning earlier, the mobile apps, the data stores where you will be able to do your, all the data scientists in your company will be able to do their job. Well, it starts with the devices, right? Typically very constrained, very small sensors. This is actually where, when you hear in the news, IoT is going to be billions of devices, that's typically the kind of devices we are talking about, right? Super cheap sensors where actually they are actually also very constrained, right? Maybe battery powered, and it's not like you're going to run a full stack, a full Java stack there, or have necessarily a complete operating system, etc. We're really talking microcontrollers, and we're also talking devices that do not necessarily have access to the internet, right? And that's what we want to do. We want to be able to, and that's very small for you to see, but the kind of the flow of information between the physical world and the applications is in the form of telemetry information, like data, sensor data being acquired, and also the other way around, commands, like the ability to to tell a light bulb that you want to turn it on or off, or to tell a device that, guess what, there's a firmware upgrade for it, and you want to actually perform a firmware upgrade. So how do you get those constrained devices to communicate and to make it to the internet eventually? Well, this is by means of gateways. So gateway, think Raspberry Pi, right? Although in an industrial solution, it's probably going to be something more ruggedized and more industry ready, but that's really like a small computer, if you will, that's going to have a way to interact with the devices, with the sensors over Bluetooth Low Energy, or over maybe CAN bus if we are talking automotive, etc., etc. And on the northbound interface, if you will, it will use a protocol such as MQTT actually, or maybe HTTP to effectively upload the telemetry data to the cloud. And this is where maybe most of the stuff is actually going to be very similar to the good old internet, right? It's not like we are reinventing ways to create internet backends and web backends, but there might actually be also some specificities there, and hopefully the server infrastructure is going to expose APIs that are going to allow the data to be accessed by, again, the mobile apps, the dashboards, etc. So it's actually nothing particularly fancy, I guess. A few things to keep in mind. When I think devices, and when I talk to you about devices, it's really constrained sensors, cheap, typically, right? You want them to be cheap. If there are to be vibration sensors in each and every equipment in your shop floor, if you can save 10 cents by getting rid of a GPIO on the microcontroller, or by getting rid of 10Ks of RAM because, well, you actually don't need them and they're actually not cheap, well, you'll do it. So there's lots of choices to be made when it comes to developing the device, the sensor software, that being added to the fact that you typically want to save also on the power consumption side of things. Probably the sensor is going to be battery powered. So in terms of software, in terms of developing the actual software stack for the device, it means that you will have to make choices, right? And you will have a very specialized software running there. The good news is, by means of the gateway, there you have way more room to basically communicate with your devices, and maybe more room for first bringing the connectivity part, like the gateways typically be something that's mains powered and that does Wi-Fi, cellular, maybe satellite, depending on where you are. And the first aspect is really going to be about providing the connectivity and turning the information that you get from the physical world, from the sensors, from the devices, turn that into actual meaningful messages, right? Messages that are going to be sent to the server. And also the ability, because we're talking something like 1 gigabyte of RAM and kind of a fairly capable Linux box or fairly capable box, you can start also doing some so-called edge computing, right? What does this mean? It means that, again, back to the example of maybe vibration sensors in each and every engine on your factory floor, this will be a lot of data that's going to be generated, right? Maybe every second you're going to acquire data out of, 1,000 sensors on your factory floor. At the gateway level, maybe you can start being smart and realize that, well, if the values are not changing that much, I might decide that from the gateway to the cloud, the kind of data that the kind of telemetry information that I'm going to upload will have been pre-processed by the gateway, right? So how do you develop this software stack? We'll see as well. And in the cloud, I'd like to stress that there's probably nothing that's incredibly specific to IoT, except maybe that in terms of scalability, billions of devices, that means lots of information. So first, scaling in terms of scaling horizontally, if you will, and using all the kind of techniques that are available there. Scaling vertically as well, probably. That is, if you are to, if we all are to build IoT, our backend systems, they will have to deal with very different use cases, right? A shop floor where you have thousands of sensors sending data every second to the backend is probably fairly different from maybe a home automation system where you acquire data way less often, and the use case is very different, and that means that the architecture choices on the backend might actually be slightly different. So long story short, the cloud, it's all going to be about enabling integration with third-party systems, right? It's when you build an IoT solution, you want to allow people to access the data so as they can create their own and add their own value on top of whatever sensor information you will have made available, right? So in the past few months at Eclipse, we spent some time with our community, actually, to think about what are the typical building blocks in each and every software stack of an IoT solution, right? And then I will be digging into it a bit more. In a nutshell, at the device level, it's about it's mainly two things, I would say. Providing a good hardware abstraction layer, in that when you build an IoT solution, there's going to be lots of different microcontrollers out there, lots of different architectures for effectively implementing sensors, and maybe some of them will be ARM-based, and maybe you'll realize that it's going to be cheaper or more power efficient to switch to TI and whatnot. So how do you create software, like the kind of software you would put in your smart thermostat or on the actual vibration sensor? Are there ways to make that somehow portable, right? And second is remote management capability. However constrained your sensor, your device is, if you cannot update it, and if you cannot remotely manage it, as in not only monitor the health of the sensor, like the battery level, etc., but also being able to upgrade the firmware, the actual firmware over the year, then you're going to be in trouble real soon, right? Because you don't want to go and send the technician update each and every 1,000 sensors that you have on your shop floor if you realize that there's a security issue, or if you realize that there's just a bug, right? So how do you do that? What's available to do that? We are going to see that. At the gateway level, it's really about enabling, like I said earlier, turning the information that you get from the sensors into meaningful messages. So the role of a gateway will be to support protocols such as the field protocols that allow to talk with the sensors. Here we're talking about Bluetooth, maybe CAN bus, Modbus if you're doing industrial automation, and also support the IoT protocols that are going to allow the gateway to actually send data to the cloud. So maybe here we're talking MQTT, or maybe CoAP, or maybe lightweight M2M. And at the gateway level, what you want is essentially a router on steroids. In that, like it's just like in the good old internet, you want to bridge devices to another network, essentially devices, sensors that don't necessarily have an IP stack, yet you want to bridge them to the internet. And what's more, you want to deal with the fact that in a typical IoT network, the gateway, it's likely that it's going to rely on some kind of maybe cellular network, right? Because you have a gateway sitting in the middle of nowhere, or like, yeah, I don't know, you're monitoring the electricity production in your house in the middle of nowhere, and this is being sent over cellular, right? And maybe the cellular network is not that reliable. How do you deal with the fact that you as an application developer when you want to send data to the cloud, you don't really want to have to deal with the fact that, the network is down, I need to store the data locally, and maybe eventually it's going to be back, and I'm going to push the data. That's not really convenient, right? So that's also a feature that you would expect from the gateway. In the cloud, it's about being able to store the data. So I guess nothing really new there. Exposing APIs, so as people can consume the data from the fire hose, pretty much. But it's also about being able to, so that's for the applications, but you also want to operate your equipment. So how do you do the device management from the cloud? How do you have a representation of what is the version of the software that I'm running on my devices in the field? What if I want to update my fleet of devices and push software upgrade there and monitor how well it's going over time? So that's the kind of feature you would expect from the cloud backend. Some cross-layer concerns, such as obviously security. How do you make sure that the solution is secured, and that goes all across the three stacks, I guess. Ontologies, how do you make sure that the data that you're manipulating, you kind of know what it is you are manipulating when you have a temperature data, temperature value ending in a data store that says, that's, I don't know, a float that's 72. Is this 72 Fahrenheit or Celsius? How do you, all the way from the sensors to the cloud, keep track of that kind of information? And everything, tools and SDKs, what can help support IoT developers, maybe simulators, debuggers? Is there anything specific needed there? Probably. So that's like, I would expect everyone building an IoT solution to somehow fit into this architecture, and actually there's lots of existing commercial solutions out there that do just that. However, what's really important is that if we really want to build an IoT that's interoperable, as opposed to silos where, I don't know, you have a Nest thermostat at home, how are you going to get the Nest thermostat to interoperate with another gadget that you may have from another vendor, right? The Nest architecture is very likely looking like this. There is a sensor, and maybe for the gateway, it's relying on your Wi-Fi box at home, and maybe or the DSL box, and it's probably providing this kind of functionality. And this would be the Google Cloud backend. But in like the communication between here and there, it's likely that the Nest is actually expecting to talk to the Google Cloud backend. That's not necessarily desirable. What's important is to identify clear interfaces between each stack, so as they are all loosely coupled, including within each stack the ability to replace possibly one component by another. By this I mean, say you're building a gateway stack, and you will start creating software that's going to access, again, maybe your vibration sensors. The gateway might come maybe with a communication layer that's relying on HTTP for publishing the data. Is there a way to replace this by maybe an MQTT communication layer, so as the communication is effectively going to be more efficient, but the rest of the software that's running on the gateway is going to remain just the same, and it will be communication standard agnostic pretty much. The platform independence, that's, I guess, particularly important both from a constrained device point of view as well as in the cloud. For the constrained devices, like I said, you may want to write software that targets ARM initially, but realize later on that there are cheaper options out there, so you want to move on. In the cloud, that's the ability to Docker to make it simpler, but that's also the ability maybe to run your software stack on top of OpenShift or on top of Cloud Foundry. That's something that's to be expected from IoT software, right? Many open standards that help in that regard. And that's basically, that was my long introduction to walk you through how we do it at Eclipse. We are, so Eclipse has lots of stuff around the Java IDE. Yes, sure, but that's a long time ago actually. Now there's way more, and especially around IoT, we have those companies, big guys actually, like Bosch, Canonical, Red Hat, GE, IBM, Siemens, Cisco, many others. They are working on providing the software for implementing the IoT stacks in open source. If you've been involved or following and tinkering with IoT maybe somewhat in the past 5 years, you may have heard about some of our so-called building blocks. So there's actually 30 different open source projects at Eclipse. Many of them you can use independently, right? Which is great, but we hope that we can also get to a point where those different components can also be used in the form of stacks, right? Rather than just getting a communication stack that you will have to integrate yourself in your microcontroller. What if this was combined with some kind of hardware abstraction layer as well as the device management stack, and then you basically get a stack that you can run on your controller, right? That's what we're trying to do for devices. So in the next few charts, I will be doing lots of name dropping, I guess. I would hope that if some of those projects sound interesting to you, you will either check out their websites. Some of them will be featured in my demo later on, and or you will come and find me if you want to ask questions. Hardware abstraction layer, there's a very cool project that you might want to check out. It's called Eclipse Edge. That's essentially Android for microcontrollers. It's providing a Java API for abstracting out the capabilities of a microcontroller. So the access to the UART, the GPIO, if those names sound familiar to you guys, the access maybe to a file system if there's a file system. And then it's expected that, so by means of having this common Java abstraction, then you can start writing Java code, essentially. So that's going to be portable by definition. And there are actually out there some microcontrollers that do run an embedded JVM. And so no matter the actual flavor of the VM, there is a very small, minimal subset of APIs that you can use to effectively develop code on your micros. Assuming that your constrained device has IP connectivity, which sometimes happens, maybe it's going to be able to talk Wi-Fi directly. You may want to use the MQTT protocol there in just maybe a few sentences, because I think many of you didn't seem to know about MQTT. It's a fairly old, actually, protocol invented in the mid-90s, I believe, by IBM and Arcom, and it's a pub/sub protocol, nothing particularly new here, except that it's meant to be super lightweight in terms of footprint on the wire, footprint of the actual messages, lightweight in terms of complexity, if you will, like the workflow of an MQTT communication scenario is fairly simple, so it means that it will be kind on your battery life. And yeah, there's lots of flavors of PAHO, and if you want to run, of MQTT implementations, and at Eclipse, that would be under the Eclipse PAHO umbrella, and if you want to run an Eclipse PAHO and an MQTT embedded stack, you could certainly get it from Eclipse PAHO. Eclipse Wakayama, that's the kind of stack, so that's an implementation of the lightweight M2M standard, which is a standard for device management. So on top of UDP and on top of the Cora protocol, it provides a standard way to query a device to obtain a battery level information, or to query a device and obtain how much memory is available, or to tell a device, here's your new firmware, please update yourself. And it provides all the workflow for doing just that. At Eclipse, we have a rock-solid implementation. It's called Wakayama. It's being used by the likes of Bosch, Sierra Wireless. They actually put it in very constrained modules, and they have a way to control the modules. Like I said earlier, it's a very important aspect of IoT. Yeah, a few more words about Edge. So I think I told that already. It's really the hardware abstraction layer. And just to tell you how small it can get in terms of actual targets, this is an ST microelectronics board. It's kind of slightly more powerful than an Arduino for those who are familiar. I guess it's close to the Arduino Mega. This can run Java, and you can actually write some Java code to access the LEDs. Maybe if there's some kind of display attached to the microcontroller, you're going to be able to drive that as well. So that's a very cool project. You should check it out. Moving on to gateways. Two solutions available for kind of full stack solutions for gateways. One is Cora, and I'm going to show Cora in my demo later on. It's all the features for having, like I said earlier, a router on steroids. So the ability to build an IoT router / gateway. It's based on Java and OSGI, and it has lots of built-in features for, just like Windows OpenWRT in the room. Is this something that sounds familiar? So that's OpenWRT is an open source stack for internet routers and for Wi-Fi routers. So the features that you expect there is the ability to manage maybe a firewall, the ability to do to manage all the different connection mechanisms that you will have, such as Wi-Fi, cellular, etc. You want rock-solid support for that, especially since maybe Cora and your gateway there might be different flavors of the underlying operating system, yet you want a consistent way to effectively manage everything, network management. You want a consistent way to have access to all the protocols, such as, again, CAN bus, Modbus, etc. You're going to require to talk to your devices or maybe to talk to your cloud. And you want features as well, such as, because the goal eventually is really to enable people to build their own applications, right? There's going to be a gateway whose role, and that's what Cora is built for, the role is going to be to provide the connectivity to the equipment, and making sure that it's remaining connected to the Wi-Fi, and maybe if the Wi-Fi dies, it's going to fall back to cellular, and that's going to make sure that this happens. But that's not enough. It's also going to allow you to create your own logic, deploy your own plugins, if you will, so as assuming that the connectivity is there and Cora is taking care of that, you're going to be able to be like, okay, I'm building a vibration sensor monitoring solution. I'm going to deploy code that's going to interact with sensors over maybe BLE and use the Cora APIs to publish data to the cloud, right? So that's how Cora works. Provides a nice GUI for effectively controlling and configuring the gateway, the kind of interface that the operator of an IoT solution might use, right? When you start deploying the vibration monitoring solution in a new factory floor, someone is going to effectively go and deploy a gateway and maybe configure it right from the web GUI, or maybe configure it over the air. Like as soon as there is connectivity, you can do that over the air, which is quite convenient because when you have thousands of shop floors, you don't want to go on site to do maintenance, right? Another option for building an IoT gateway 100% based on open source would be Eclipse Smart Home. There's actually a talk later on this afternoon from the Smart Home project leader. There it's all about home automation. So built-in rules engine for doing if then that kind of, if temperature in my bathroom is above 20 Celsius, then turn the heating down and stuff like that. Built-in support for many of the protocols, if not all, that you would find in home automation, Philips Hue and LeafX and KNX and whatnot. And fairly nice, really nice actually, UI for manipulating all your gadgets. Moving on to the cloud. We have many building blocks that can be used for helping you build the server-side components of an IoT solution. Two very interesting ones would be around device management. I mentioned lightweight M2M, so that's like the protocol that's being used for doing firmware upgrade and monitoring the battery, the memory, etc. of your devices. With Eclipse Wakayama, you have a very lightweight stack lightweight implementation of lightweight M2M that you're going to put in your microcontrollers. With Eclipse Leshan, you have the server-side counterpart of Wakama that's going to be what the devices are going to be talking to, right? But that's not necessarily enough. Like Leshan and Wakama, that's basically just the protocol stack. When it comes to upgrading IoT, and that's probably very, very unique to IoT, actually, you have actual devices that you need to manage, right? When we build, I don't know, a mobile app, we probably rely on Apple and Google for everything, software upgrades. That's going to be their stores that are going to take care of that. In IoT, you're actually in charge of your fleet, right? And so you have 1,000 gateways, and there's a bug. There's a bug, and there's a new there's software update that you need to push, and it's 100 megabytes of binary. If you tell all your devices to call home at the very same time and download 1,000 megabytes worth of binaries, you're going to have many issues. First, maybe the server will just not be able to handle the load. Second, what if in this update there's a bug as well? Basically, you're taking the risk to break all your devices at the same time because, well, you thought it would work, and okay, your devices, go and download the update, oh, oops, sorry, it doesn't work. With Hawkbit, you actually have the way to manage the workflow of rolling out the software over time, maybe creating partitions, so as you start on like a very small subset of your fleet, check the success rate there and take it from there. So that's something that you really want to check it out. It's being used by Bosch extensively these days for doing their own software rollouts. Data ingestion in the IoT backend platform. Eclipse Mosquito can take care of that. That's a server implementation of the MQTT protocol. It's a really, really popular MQTT broker that they may want to use. But yeah, that's building blocks, and that's not really enough in that what if, like, when you want to build a real IoT cloud, you may have many concerns in mind. Well, first, all those building blocks, they don't necessarily communicate with one another. So authenticating the devices that are going to send data to the MQTT broker is going to be required, just like you will need to authenticate the devices that are going to do lightweight M2M stuff. And maybe there will be users as well, et cetera, et cetera. So you need some kind of integration platform, right? And that's what Kapua is about. Kapua is the platform where all the building blocks will be deployed, if you will, as microservices. So Kapua provides the infrastructure for having one single notion of a user, one single notion of a data store. And so there's going to be like description of how data is expected to look like in a Kapua context. And then maybe the data store, effectively, the microservice is going to be implemented by means of Elasticsearch, or maybe some other people are going to will want to provide an alternative implementation based on OpenTSDB. In which case, what they will do effectively is create a new microservice in the Kapua runtime and take it from there. And Kapua is also taking care of providing top-notch integration with cloud infrastructure such as OpenShift or Cloud Foundry. And so these days, there's lots of development happening around Kapua with lots of activity from Red Hat, Eurotech. You can go check out the code. It's available as a Docker image, essentially. So what I actually highly encourage you guys to do is check out Cora. You can get Cora on your Raspberry Pi very easily, or run it in Docker. Get Kapua as well. Fire up a Kapua instance using Docker in some VM somewhere, and start connecting your Cora gateway to Kapua and see what you can do there. You can start doing device management. You can start having Kapua behaving as a device registry, and whenever new gateways are going to be connected to it, you will see them. You will be able to maybe revoke their credentials if the gateways are being compromised. That kind of stuff. A quick few words about the cross-layer concerns. Keep keeping on the name dropping aspect, Eclipse Kitty, that's proposed by GE Digital. That's OAuth on steroids. So that's essentially the ability to model roles for like either having read access, write access, firmware upgrade access to devices, to attributes in a data store, and the ability to use these rules that are being modeled to be like, okay, I'm Bob. I am a data scientist, so I have the role data scientist. I have the role I live in Northern California. Dear Kapua or dear Kitty, can I get a token to access this device, to read data from this device? And depending on whether you actually have the rights or not, you will get the token. So that's a really complete solution. You can go and check it out. The code hasn't been moved to Eclipse yet, but it's actually already on GitHub though. It's called ACS Predicts for now, and it's going to move to Eclipse. Ontologies, check out the Eclipse Voto for everything data modeling and the ability to use models like the description of the capabilities of a sensor or of an actuator, and use that to maybe generate code or to do data validation or to do data conversion. That's that's something that's really taking off actually, and there's an online repository with all the information models for sensors that people can populate and curate as well. In terms of tools, a few things that you may want to check out. If you're doing MQTT, MQTT Spy is a really nice JavaFX UI for spying and monitoring MQTT communication. So you can create charts. You can use MQTT Spy for recording MQTT communication scenarios, do post-mortem analysis, that kind of stuff. Eclipse, of course, the Eclipse IDE for C or C++ development, Eclipse Che, and Eclipse Titan is for testing. For testing communication scenarios like at scale, you want to do maybe load testing and that kind of stuff for MQTT, co-op, etc. And that's what Titan will provide. So there's lots of building blocks, like I said, but there's also stacks, right, that you can use, such as Cora, Eclipse Smart Home, Kapua for building your IoT solutions. At this point, I'm going to move to the demo. Can someone confirm that I have until 11:10, right? That's 50 minutes, correct? Okay, thanks. I just wasn't sure. So the next minutes are going to be a demo. So we have 30 different projects, so it's kind of like I won't be showcasing them all. I will be focusing on using Cora and Kapua to build an actual solution. What's my solution? I'm a shipping company, like such as FedEx or UPS, I guess. And sometimes the parcels that I need to deliver are like super valuable. Think like if I'm shipping or if my customer is shipping Mona Lisa to a museum somewhere from the Louvre to the Met, it's like super valuable, and I want to be able to tell my customer, your Mona Lisa is fine, it's not going to be damaged in any way, because we're basically going to put a sensor on the parcel, and we're going to be able to track that. We, as FedEx, we're going to be able to track that, and you, dear customer, you will be able to do that as well. So how do you do that in practice? Well, the sensor part is probably fairly easy. For the sake of the demo, I'm going to use a Texas Instruments sensor tag, so that's a BLE temperature / humidity / a few other things, accelerometer, etc. sensor. So that's going to take care of like monitoring the physical information. But then Mona Lisa is going to go through a couple of airports, a couple of delivery trucks, and how do you make sure that this guy, who's not like IP capable in any way, finds its way to the server, so as eventually, like, I want to create a dashboard for my customer. I want to create a dashboard for my FedEx employees. So data needs to make it to the back end, right? It needs to make it to the data store. So what's going to happen is that by means of Cora, we can deploy gateways, for example, in the delivery trucks, and deploy software that's going to talk BLE, get the data from the sensor, push the data to the cloud. And what's interesting with Cora is that maybe my trucks, my FedEx trucks, yes, I own them, so like I have some flexibility to create my software. But when it comes to deploying software in the kind of gateways that would be within the airports or within the trucks on the floor at the airport, there I don't quite know what those guys are going to running, what kind of hardware it's going to be. But by means of Cora can be easily ported to many platforms, and it's actually already been ported to many platforms. It can run on many flavors of Linux. It can run on Windows, and it can run on ARM-based architecture, on Intel-based architecture. So it's actually going to be easy for me to provide some software that hopefully the airports are going to run, and that means that this guy is going to be able to get connectivity and to be routed to the internet, hopefully all the time, right? So what's happening is that in Cora, I'm going to have some code that takes data from the sensors, uses MQTT to push the data to the Kapua backend, and then from Kapua, by means of APIs, I can easily create an AngularJS application that's going to consume the data and display the data and maybe do more in terms of sending alerts when it comes to, okay, the parcel is effectively too hot right now, too warm. Let's send an SMS, right? So maybe some of the rules will be executed here. Maybe some more complex processing will be done in the backend. So let's switch to Cora. So this is my truck pretty much, and that's the Raspberry Pi, the gateway running Cora that you would find in the truck, right? And so that's how Cora looks like. Let's just refresh to make sure we start from something that's nice. And so the Cora UI, that's the web UI, that's something that a technician on the field would access to configure the gateway. And to, like I said earlier, one of the things that Cora will be taking care of is the network configuration. And no matter whether you're using a Windows operating system or a Linux operating system underneath, or Debian or Fedora, there's a consistent way to configure the network, which is important. We're talking gateway. So in the track, the gateway will need to talk cellular to get the connectivity. So you will have an interface that you need to configure there. Or here, in my case, that would be maybe wireless. So configuring wireless, for those who've tried to configure Wi-Fi on Linux, like in the command line, that's quite tricky, actually. So by means of Cora, you have a consistent way to connect to your hotspot, or to actually effectively have the gateway behave as a hotspot. So everything network management, including configuring a firewall and having some DMZ, maybe mounting a VPN. That's also a very interesting feature for M2M kind of use cases. Cora can take care of, right? What else? The ability to do everything device management, like from my console, what's the uptime, what's the GPS location of the device, what are the different OSGI bundles that are currently running, the ability to maybe execute some shell commands. I think I have a password for that. So let's execute a command, and that's going to be, oops, sorry, where am I now? Execute a command, right? And no matter what's the underlying OS, I have a consistent way to do troubleshooting mostly, right? So that's the contents of my file system, it seems. And what else? Well, that's what Cora will do, like out of the box. It will manage the gateway, but I want to do more. I want to be able to run my own software, my sensor access kind of software. So there, what happens is that you're going to use the Cora APIs to create an OSGI plugin, essentially. So you have APIs for accessing the serial port of the gateway, APIs for accessing Bluetooth Low Energy, APIs to communicate with the cloud, APIs to communicate with the GPS if you have a GPS, And you're going to create a Java app, which eventually you're going to package. You're going to create a zip file, if you will. And you can use the Cora web UI to install new software, which I actually already did. So looks like I have at least two components deployed onto my gateway right now. And what happens then is that those apps that you create, they will provide new functionality, obviously new services into your Cora runtime. And you can very easily make them visible in the UI so as people can configure them, right? And that's exactly what happened here. Next to some of the built-in services in Cora, such as the web console service or the command service and whatnot, I now have also more in the form of my own app that's going to talk to the TI sensor tags, and it exposes lots of configuration parameters, and I have a standard way in Cora to do that, and it will automatically show up in the UI, and I don't have to reinvent the wheel there in terms of making my app configurable. And what happens there is that my app will scan for TI sensor tags in proximity, and every 5 seconds it will acquire the data and publish the data that it's acquired every 10 seconds. And so what's happening then is that this data is being, we want the data to be pushed to the cloud, right? And so me as the application developer, when I built this app, I don't really want to kind of hard code what cloud backend I want to talk to. Of course, I want to have this as a configuration option. And I do not want to either to have, like I said earlier, to manage the complexity of the Wi-Fi hasn't been configured yet or is down. I'm at a conference, the Wi-Fi is down. I was about to send data to the cloud, but it's down, so I might as well store that locally and push that later on. No, Cora is taking care of that once and for all. If we go in the Cora configuration UI, once and for all, I can configure what cloud I want to talk to and what MQTT backend I want to send the data to, and I do that once and for all. And I can also configure how long I want my local buffer to be when the network is down. How many messages do I want the gateway to store locally before discarding messages? So that's my Cora gateway being configured, being connected to the cloud, hopefully. So the cloud in my example is actually, that's for the sake of demoing the interoperability. That's actually a commercial cloud from one of our member companies, which is built on Eclipse Kapua. So it certainly provides a bit more in terms of eye candy and of like fancy dashboards. But apart from that, it's very close from Kapua. And here, just quickly checking that data is being sent. I am not logged in, so I need to, there was a timeout there, I guess. So let's see if the data is being sent to the cloud. So that's really like the kind of backend, this cloud or the Kapua cloud would be the kind of stuff that as a fleet operator you would use to see all your devices, to troubleshoot them, maybe to push software upgrades, upgrade the OSGI plugins over the year, etc. But if I am to look at all the devices that are connected, it looks like my gateway is actually connected right now. By the way, so again, this is a commercial cloud, but this particular UI is just exactly identical to the one from Kapua. The things I could do include the ability, just like I did earlier, execute a shell command locally onto the gateway. Here, that would be from the cloud, that I'm actually doing just the same, accessing the very same service that we saw earlier, but this time from the cloud, and executing the command and getting a result. Trying to check what are all the software bundles that are running, just like I did earlier. I can do that over the year. And as opposed to doing it on one gateway, here I can do it across all my, 3 apparently. I only have 3 devices here, but I could have obviously thousands. And so that's my backend, and this backend is exposing APIs. those APIs allow me to build a UI, right? And the UI in my case could be this UI over here, where I've been using AngularJS and a bunch of other things to basically display the data. I can maybe also discover, like, if there's new devices, new sensors, new parcels showing up, I can start adding them to my dashboard, query the Kapua backend to discover the new sensors that are and the new shipments that are being made available. But in my particular case, the shipment, the current one is this guy, and we can see that here, every 10 seconds, we get new information. So let me try to warm the temperature sensor, and hopefully either the humidity or the temperature will go up. And if they don't, that's just the demos that are against me, right? Yeah, it turns out that. Or maybe 26.7 Celsius is already kind of the maximum I can get to. You get the idea. And with that, I think I'm actually running out of time for good. So let me just, so that's us, like lots of code, lots of projects. Again, if some of the names, some of the features that I described rang a bell, please come and find me afterwards. I'd be happy to chat some more. Yeah, lots of companies adopting Eclipse IoT. That's actually from a Bosch conference last week, sorry, and they were telling how they're building on top of Eclipse Hogbit, Eclipse Leshan, and Eclipse Vorto, etc. So that's really good to see. We do a lot for education. If you don't know the Virtual IoT Meetup, check it out on meetup.com. We do webinars every other week. We organize developer challenges. We make the software available on the Eclipse Marketplace, just like you can install plugins in your Eclipse IDE from the Marketplace. You can install plugins in your Eclipse Cora environment from the Marketplace or in Eclipse Smart Home. So that's us, that's it. IoT.eclipse.org is our main website. This is where you will be able to find the links to the project, the links to the getting started tutorials and whatnot. I hope this was informative. I realized that there was lots of information, that the demo is also a very small subset of all the things that I mentioned. But yeah, I'll be around. If there's questions, I think we might want to take them off the room. Apologies for that. There was really too much information, I guess. So that's it. Contact info here as well. Thank you very much. Quick question? No? Sure. It is? Yep. So on the slides, there was a project called Eclipse Milo. Eclipse Milo is an implementation of OPC UA. So that's a standard for industrial automation. And Eclipse Milo provides the Java stack for building both client and servers, as well as the test suites for like making sure that maybe you're going to use Milo against something else. You can maybe test that it'll work well. The security story is also pretty nice in Milo. Like, yeah. You seem to be familiar with OPC UA, I would assume. So okay, so yeah, OPC UA is kind of the next gen, I guess, of Modbus. So they use certificates for security, etc. And so yeah, Milo would provide all that, and they have lots of great sample code actually. So yeah, check it out. All right, thanks.